Hey there, this is Mr. Alexander, and today I want to talk about transformations of the square root function f of x equals square root x. You might remember this graph and this table from the first 6 weeks. A few key things to remember about the square root function. The parent function starts at 0, 0, and it doesn't have any negative x values because, of course, the square root of a negative number is an imaginary number. We talked about that last semester. The domain and range are both from the parent function starting at 0 and extending right forever, and also starting from the y value of 0 and extending up forever. So that makes the y-intercept and the x-intercept both 0, 0. There's no maximum because it's going up forever. There is a minimum at 0, 0. And the starting point. There's no symmetry lines, and there's no asymptotes. So we're going to be using this table in just a moment, so I'll keep this nearby. What I want to talk to you about are problems like these. We have a function. You're supposed to generate a table of values. You're supposed to graph the function, and then finally state the domain and range. So I just thought maybe we'd work through this problem together. Now, the first thing I like to do is with this function is I want to identify the transformations that are occurring. And the reason we're doing this is I want to be able to generate a table of values without having to use a calculator. That's the whole idea here. So I see 3 transformations. I see this negative, which is a reflection. I see this minus 3 under the square root. Now remember that minus 3 is counterintuitive, so that's actually telling me that I'm moving left or right, and in this case, since it's minus, I'm moving right 3, and then that plus 4, on the outside of the square root, that means I'm going up 4. Now, I can go ahead and graph the vertex already, because look, this thing starts at 0, 0. The parent function starts at 0, 0. But I know that it's going to move right 3, and up 4. So from 0, 0, I'm going over 1, 2, 3, and then up 1, 2, 3, 4. So this function starts right here at 3, 4. I'm going to go ahead and write that point on this table here, 3, 4. Now the question is, how do I generate some other points? And there's a bit of an art to doing this because you don't want to have nasty numbers. You want numbers like this, 1, 2, 3, and 4 that you can actually graph. We want whole numbers. So when we were looking at the parent function, the way we did that is we started at 0, 0, and then we selected some x values that we knew would give us whole numbers. The way we knew is because these are this 1, 4, 9, 16, these are perfect squares. So we kind of want to use the same process. The way I want you to think about it is, okay, from 0 we went right 1. And then we went right 3, and then we went right 5, and then we went right 7. We're going to follow the same process here. From 3, we're going to go right 1. So we're going to find the point at 4. So 0 to 1 was right 1. 1 to 4 is right 3. So I'm going to find the coordinate at 7, comma, another one. And from 4 to 9, we went right 5. So from 7 plus 5 is 12. Now obviously I'm not going to be able to graph all of these because this graph only goes up to 7. But I'll be able to get these two. Now to figure out what the y-coordinate is, you just plug it in. So I'm going to plug in 4 for x. 4 minus 3 is 1. Times a negative is negative 1. Negative 1 plus 4 is positive 3. So that's a coordinate. See how it's a whole number? We use these perfect squares. You follow this pattern, you're going to end up with a whole number every time. All right, let's plug in the 7. 7 minus 3 is 4. Square root of 4 is 2. Negative, so it's negative 2 plus 4 is negative 2 plus 4 is 2. Now notice how the y values are going down. That's because it's a reflection. This thing is extending downwards. All right, let's do this last one. 12 minus 3 is 9. The square root of 9 is 3. Negative makes it a negative 3. Plus 4 is 1. So I'm going to write these values in here. So the big thing to remember here is the process. So you start at the vertex, you go right 1, you go right another 3. So from 3, I went right 1 to get to 4, and then I went right 3 to get to 7, and then you go right 5 to get to 12, and then of course you could just follow that process along. Just for fun, let's try the 2 right here. 2 minus 3 is -1. The square root of -1 is I. You can't plot an I on an XY axis. So we just call that, we put a little dash there because we can't graph it. In fact, any point over here would be a dash. So all the points above this 3, 4 are ungraphable. So we know this thing is just moving to the right. And in this case, it's going downwards because it's a reflection. And we'll see that when we plot these points. So I already plotted 3, 4. 4, 3 is right here. 7, 2 is right here. And I can't get 12, 1, but it'd be like somewhere out here. To make it a square root function, don't forget to put an arrow at the end of the curve there, because that thing's extending out forever. So let's just talk about the process one more time before we do the domain and range. The important thing to do, find the vertex first. Right 3, up 4. From 0, 0, that's right 3, up 4. Now to generate the other points, take that x value, take that 3 from the vertex, and go right 1, then go right 3, then go right 5. That'll get you whole numbers so you don't have any trouble graphing. And then to get the y values, you're going to take the x values you just generated and plug it back into the function. That's how we did all this. Let's talk about domain and range. The domain, we're supposed to use inequality notation. So what I like to do to just make it simple, there's different ways to do this, but I know that the range is y's and the domain is x's. And I know I'm using inequalities, so I just put some inequalities in here with an x and y, and what I need to do is fill in these numbers that go on this side. They're different, like I said, there's different ways to do this, but this process will get you the right answer every single time. This is the way I like to think about it, because the domain is how far left to how far right. So ask yourself the question, what's the furthest left x value on this graph? In this case, it's 3. Okay, what's the furthest right x value on this graph? Well, that thing's going right forever, isn't it? So that's infinity. The range is how low, what's the lowest y value, and what's the highest y value. Well, hopefully you can see this thing's going down forever. Slowly, but it will go down forever. So that's negative infinity. And then this thing goes up, the highest y value is 4. So it's from negative infinity to 4. And that's how you do it. That's how you're going to do these. Process is exactly the same on all of them. Takes a little bit of time to graph them, but that's okay. I also want to talk about, if you're looking at a graph, how you might figure out what the function is, how to write the function. And I'm thinking, let's just talk about this one, b here. It's an inequality, and it's shaded below, and it's a solid line. So every time we're going to have f of x something. And again, it's shaded below, so that's going to be less than, and it's a solid line. So it's not only less than, it's less than and equal to. Over here where it's shaded below and it's a dotted line, that's going to be f of x is just less than something because it's a dotted line. But since this is a solid line, it's f of x is less than or equal to something else. The question is, what's that something else? Well, hopefully you can see it's a square root function. That's pretty obvious, a square root function here. So I'm going to put the square root here, square root x something. But there's a few transformations that are taking place here. The first one you should always check is it going upwards or is it going downwards? If it's going upwards, there's no negative sign. But on one like this, where it's going downwards, This is it's been reflected, so we need to put a negative sign in front of the square root here. I'm not going to worry about a negative here, but there is going to be a number in front of the square root. And the way I know that is between the first 2 points, we go up 2 over 1. Now let's look at that parent function one more time. Right here, in the parent function, it just goes up 1 over 1 between the first 2 points. Up 1 over 1. So that's why there's no number in front of the function. There is a number, it's a 1, but we don't write 1s. So since this thing goes up 2 over 1, we're going to put a little 2 right there. So you only need to check the first 2 points to figure out what's the number in front. Now, from 0, 0, this thing has moved left 1, 2, 3, 4, 5. So that's left 5, and it's gone down 1, 2, 3. Left 5, down 3. So to make this thing go left, remember underneath the square root is left and right. So to make it go left, you're going to put a plus 5, because underneath the square root, it's counterintuitive. Even though we're moving left, which you would associate with negative numbers, we're going to do the opposite. We're going to put that plus 5. Now to make it go down 3, on the outside of the square root, we might write minus 3. Because on the outside of the square root, it's up and down. The movement is up and down if it's positive, if it's plus or minus. If it's multiplication, that's when you get your vertical shifts or vertical compressions. But this is the answer. And those are the two things that you really need to be able, the two kinds of problems you really need to be able to solve from this lesson. Thank you for watching. I hope that it was useful.